Yes, on Thursday's
On
class, I will,
okay.
yeah, give you step-by-step solutions. And so this weekend, you can, I mean, this week, yeah, weekend you or whatever, you can study that to make sure you can do every single problem on the practice exam before you take the exam. Okay.
Okay. I just
Yeah.
want to let you know you are like my only instructor that I'm actually learning from.
Oh, great. Thank you. All right. So let me see. Because well, I mean, I was a student before, so when I took exams, usually the we don't have the a study guide. I mean, it's the question is there's just a lot to study for, and we didn't know what to expect. But I feel like giving you a practice exam, you know what kind of problems will be there, and that's the problems I need you to know, and for this class. And so it's like just very clear what you need to study for. So for example, week 3 under the practice exam is posted under week 3, and which is also due today. Let me show. Yeah, okay. So for example, when you take the exam next week, the first problem will be the same type. You need to know how to find the GCF and LCM of two numbers. And the numbers you get, of course, going to be different. So instead of giving you 20 and 25, I probably change that to, any two other numbers, like maybe 35 and 70, something like that. So anyway, the type would be exactly the same, it's just different numbers. And the second type, number 2, would be adding, subtracting, multiplying, exponents, parentheses of sign numbers. And so again, I would change the numbers. So maybe I just change it to -5 minus -7, something like that. But the type will be exactly the same. So like number 6 is adding fractions. Again, I'll give you two different fractions. But the problems will be all the ones we discussed in class and in homework. So I won't give you anything like you never did it before. And this will be, so this each question represents a certain type of problem we talked about in the class. So for example, how do we divide fractions? In this case, it's how to add fractions. So that's something we need to know. And in real life, we do use that. Like sometimes my husband would be asking me, like when he's measuring something or when he's cooking, he will ask me, what is 2/3 plus 1/6? And so, I mean, we do use that in real life. Okay, and so like this one would be decimals and all that. Okay, so anyway, every single question on the practice exam will be on the real exam. And so there will be no surprises, so you know what kind of question they are. And so that's why I'm saying it's very important that you make sure that you can do every single problem here. Because if you cannot do it open book, definitely you probably won't be able to do it when it's closed the book, right? So practice a few times, make sure you're ready before you take the exam. Um, so in the past, I had a student who told me, "Oh, I did this like 5 times." So you can redo it. Like just take out. If you have printer, you can print out of multiple copies. If you don't have printer, just take out a piece of paper and try to, redo these questions. Until you know how to do every single question independently without looking at your notes or without anybody's help. Okay, so um, yeah, that's um, uh, okay. All right, yeah. So that's I do want to talk about so this time because it's different. And normally, I just do it in the classroom. You come to class and I give you the exam and you turn it in. But this time it's different, so we have to use the online proctoring software, which I mentioned in the syllabus during the first class. And also, this is my first time using it. So, if you have any questions and we will figure out together. So under week 5, I made it available today. I posted a proctortrack student guide. So you can open that document and you can download it. And it tells you everything you need to before you take the exam. So, for example, you need an ID, and you cannot use a cell phone to take it. It has to be a computer, and it cannot be a Chromebook. And also, the web browsers, it has to be either Chrome, Google Chrome, or Firefox. It cannot be, I think, Internet Explorer. So anyways, so that document will tell you everything you need to know. So first, you gotta read that document sometime this week, and there's an onboarding exam, which is like a trial. It has no points. It's just get you like a practice, something you try, and then to know how the proctor track works. Um, and also, I made a video posted under week 5, and you can watch the video. It shows you everything about that. I'm gonna go over it a little quickly here. So the exam will be 2 hours, and I'll give you extra 15 minutes to submit your work because you do have to take pictures of your work, just like you did with homework assignments. So take pictures and upload it when at the end of the exam. So it's gonna be like 2 hour plus 15. I know in the past, from the past experience, usually most students probably can finish it in 1 hour. So you probably don't need 2 hours. Um, and if you're very familiar with all the province, it probably just gonna take you like 30 minutes. In the past, I had a student who finished the exam in 30 minutes or even less. Uh, so I don't think you need to worry. You should have enough time to do that. I was trying to see. I think somebody typed something. Okay, so let's see. So this week, sometime this week, try to take the onboarding exam because you do have to. Um, okay, so you don't have a student ID. Do you have any ID like a driver's license or as long as it has a picture? Yes, yeah, you can use your just have any. I think it's mentioned in the document. Yes, driver's license should also work. Okay, good. Yeah, the Chromebook doesn't work. That's what I said in the document. So in that student guide, do you have any other computer, laptop or computer desktop? If you don't, you might be able to borrow one the from OU. The worst case, yeah, the desktop it will work. Just as it cannot be a Chromebook because you have to install a software. Because I don't think you can install software on the Chromebook. Um, so that's what it is. So that's why I need you to try that onboarding exam to make sure your computer works. It checks verifies your computer whether your computer meets the requirement or not before you take the exam. The worst case, so I'm trying to be more prepared. So if you're somehow your computer just doesn't work, because I had another class, online class, the student told me, yes, Molly, thank you. You have to have a webcam camera and you have to have a microphone because it records everything, the voice or how you're doing it. The whole process is recorded so even if you have some suspicious actions and it may be the system I think they use artificial intelligence, but if they somehow flagged it as suspicious activity, I can go in there to watch the video, just make sure you're not doing anything wrong. Um, okay, yeah, so you can learn a laptop from OU. Uh, But like I said, the worst case scenario, if you just cannot get it to work for some reason, email me and I can meet you on Teams. I can schedule a meeting with you, and so you will be turning on the camera and the microphone. I will be monitoring the exam. What proctoring the exam for you, just watching you from the from my computer instead of artificial intelligence. Uh, with the proctor track, the good thing is you can take it anytime. So although in my syllabus I did have it scheduled on Tuesday, but you're gonna have the option of taking it the whole week. So anytime next week, whenever you feel you're ready, you go take it. So you're gonna starting from next Monday till the Sunday, October 4th. So I will have everything on Blackboard. So um, the next Tuesday we won't have a class. Um, because it's supposed to be this exam day. Okay, you can use that time, these two hours to next Tuesday to take the exam if you want, but you don't have to. So just anytime next week. Yes, Tori.
I was wondering, where I already did proctor track for anatomy, I was wondering if I would have to redo the onboarding exam or not.
Oh, I think if you passed, you probably don't need to take it again. Um,
Okay.
yeah. Yeah, I think that's yeah. If you already passed it for another class, you don't have to take it again.
Okay.
Um, is that a while ago? Or just make sure your computer still works. Um,
Yeah. Um, I just did it not too long ago, like probably like a week ago or
oh
2 days
yeah,
ago.
that should be fine.
Okay.
Okay, and let's see. Yeah, I say so. You probably, Tori, you probably already know how it works. But so when you take the exam, just let me go over quickly. It is all mentioned in that video, so you can watch that video later. But what you need to do is, again, you cannot take it from here. If you click on this onboarding exam, and it will ask you begin the exam, it will ask you for a password. That's why this prevents you from taking it from Blackboard without using proctortrack. So you do have to go to, let me enter the student view. So, okay. So this is what you see, and you go click on tools, and you will be able to find proctortrack, and then click on that. It might take a little bit to load because I opened it quite a few times. If it's first time you open proctortrack, it might take like 30 seconds to load. And then you will see onboarding exam. You click on go to test. It will take you to a page that to tell you to download this software and to follow the instructions. And you do have to have ID so you can scan your face and scan your ID, make sure it's the right person taking the exam. Okay. Uh, okay. So when you take the exam, you just need to have your notebook or not the notes. Okay. Just the blank paper. I think that's all you need. And your, maybe if you use your phone to take your pictures, you can have your phone, but you're not allowed to use it until the end of the exam. When you finish, use it to take pictures and upload. And since you cannot, you have to take it on the computer. So when you use, after you use your phone to take the pictures, you will have to email the pictures to yourself. And then you download the pictures from your computer and then you submit from your computer that way. Okay. Um, let's look at, let me show you what the onboarding exam will look like. The real exam will be kind of similar. So on the onboarding exam, I just kind of showed you a couple of types of questions possibly you will see. Seconds, let me view. Okay, so how many questions will be on the exam? It's gonna be exact the same on your practice exam. So I didn't count how many are there, but how many you have here will be how many you will have on the exam. Oops. So, let's see. So let me show you what the onboarding exam look like. I'm just gonna go starting from here because I'll just try to show you what. Right. So this is what the exam looks like. Onboarding exam. So you may have multiple choice, fill in blank, and a short answer. So when for our exam, the first exam next Tuesday, I will not have any multiple choice or fill in blank. I'll just give you short answer questions. So every single question will look like this. I give you different ones, just let you play with it and see how what the system looks like. And the most important one is the last question. So the last question will be asking you to upload a picture. So here I ask you just write down something on your paper and take a picture or scan it and try to attach the pictures or scan the documents. So this is the last questions will be the one I will grade yours. I'm talking about a real exam. This one has no points, so you don't have to worry about anything. So for every single question, you would get, say, number 1, like this. Go back to practice exam. So I will have this question there, and um, and okay, so you can put your answer here. But if you don't want to bother like to learn all the symbols, because they do have a math function like this one, f sub x. If you click on that, you won't see it because then Microsoft Teams doesn't show the pop-up window. But if you click on that, you will be able to see a math window that gives you all the forms like fraction, square root. But if you think that's too much for you, don't worry about it. Just leave all the questions blank and make sure as long as you submit your work from, attach all your pictures in the final question. Okay. So in the final question, is not nothing. It's just asking you to take a picture of all your work, step-by-step work. Again, I give partial credit. So attach all your pictures and hit save and submit. Okay, so all the previous questions, if you want to learn how to type in symbols, you can if you have time to play with it. Otherwise, just don't worry about it. Leave them blank. And all that matters is the final question. Just attach the pictures. Okay, so that's I think that's everything about the exam. Okay, any other question? Okay. So just
So we don't have to type in the answer. We can just attach the picture.
Yeah, that's right. Originally, I was thinking to make everybody type in the answer, and automatically, if your answer is correct, you get 1 point. But then I figured it might be, some of the students for some students might take much longer time to figure out where to find the math symbol. I think for our class, it's not too bad. We don't have any square root or difficult ones, but just make it easier for everybody. Yes, you can leave them blank. Don't worry about those ones. So I would just grade your pictures, your documents. Yes, Tori. Tori, do you have another question?
No, sorry.
No? Okay. All right. Any more questions? Okay. All right, so let's go back to our class today. Let's stop sharing this and okay, so these are the 2 bonus questions that we did last Tuesday. I'm sorry, last Thursday. Okay, let's see. So the first one, convert 10 quarts to gallons. I saw that some students just did basic math. 10 divided by 4 equals 2.5 or 2.5. That's fine. If you know that that's what you need to do, that's fine. But we learned we talked about 2 different ways to do it. One is to use proportion. The other is just to use conversion, basically conversion factor. So I'll show you both ways how to do this. Let me get a new page here. Okay, so we first of all, I'm gonna just use the conversion factor. So we are given with 10 gallons, I think. Is that, wait, 10 gallons? Okay. Wait, 10 quarts, sorry. We're given 10 quarts. So you start with whatever there it's given. So you always write down what's given, 10 quarts, and put it in the fractional form, 10 quarts over 1. And also it's given 1 gallon equals 4 quarts. And remember, our final answer needs to be how many gallons. By the way, I think I did notice maybe one student said the answer is 2 gallon and 2 quarts. Well, what our answer, we do need you to just give us how many gallons. It cannot be a gallon and a quart. There are 2 quarts left. We don't want the answer to be like that. We want the answer just how many gallons. So you do have the extra 2 quarts. You do need to convert it to how many gallons. It's like half gallon, right? So that's what we need to do. So the final answer is just how many gallons, no quarts. In order to convert quart to gallon, that means you have to cross that out. So that's why we're using property of fractions. When you multiply fractions, the top and the bottom, if you have same thing, you can cross them out. If we have a quart or quarts on the bottom, that can cancel that one on the top. And then we can have a gallon on the top that will leave us the gallon. So that's the idea. So we look at the conversion relation between gallon and the quarts. So you can take one of them. One side will go on the top, one side will go on the bottom. So I will, well, apparently I need the quarts to be on the bottom, so I put 4 quarts on the bottom. Well, the other one has to go on the top. And again, remember, 1 gallon is the same as 4 quarts. So when you have something over something, they're equal, they cancel each other because 1 gallon is 4 quarts, right? So when you divide 1 gallon by 4 quarts, that's pretty much like equal to 1. Anything times 1 would be the self. So when you multiply something like 1, it's not going to change 10 quarts. But this format will change quarts to gallons. So after we cross out the quarts from the top and the bottom, we multiply them like fractions, straight across. Top times top, bottom times bottom. So the top, this is crossed out. So we're left with 10 times 1, which is 10. And the gallon would be gallon. So we end up with 10 gallon on the bottom, bottom times bottom, 1 times 4, because this is canceled out. So that's what we are left with. The gallon will go on the top, but you can put it right next to it. Simplify this, 10 divided by 4, you'd either get 2.5 or you get 2.5. Either way is fine. So you're going to get 2.5 gallons or 2.5 gallons. So that's the using conversion factor to do it. The other way to do it is to set up a proportion. When you set up a proportion, you can always start with the conversion relation we have. So 1 gallon equals 4 quarts, right? So I can just put 1 gallon over 4 quarts. By the way, if you don't want to put the gallon of quarts there, you don't have to. You can just put 1 over 4. Now, on the right-hand side, you make sure you're consistent. For example, the top, you put a gallon. So on the right side, the top also has to be a gallon. How many gallons? Well, the question is 10 quarts. Let me put a question down here. The 10 quarts equals how many gallons? Do we know how many gallons? We don't. In this relationship, we don't know how many gallons. That's why we need to find out. So let's call it X. I'm going to put an X on the top, and that means 10 quarts will go on the bottom. 10 quarts will go on the bottom. Again, when you do the setup proportion, you don't have to write down the gallons and the quarts. You can just think of that in your mind. So when I put it here, so you can see very clearly, top is gallon, bottom is quarts, bottom is quarts. So you don't put them in the wrong place. So pretty much we just end up with 1 over 4 equals X over 10. Now we can do cross products. They're equal to each other. So 1 times 10 equals 4 times X. And we can divide both sides by 4 in order to get rid of the number in front of X. Divide both sides by 4. As you can see, still exactly the same thing. 1 times 5 of 10 divided by 4, you get 2.5 or 2.5. Okay, exactly the same answer for that X there. Okay, so there are technically 3 different ways. One is to use what we call conversion factor. The other is proportion. And the third way is you just know it, okay? So some students might know, I just know it's 10 divided by 4. And if you ask me why, I don't know, I just know it. I mean, that's fine. But for those students, if you have trouble doing it, say, I don't know if I should do 10 times 4 or 10 divided by 4, then use the way we learned. This will help you. Okay, any question? No? Okay. The second one will be using algebra to do the question. So we learned how to convert words to symbols. Every single word here will become a symbol. So for example, 150%, that's already math symbol, so leave it. Of means multiplication. If you haven't memorized that, make sure you memorize that. Of means multiplication. What number? Well, we don't know. Well, that's the unknown, so put an X there. Is, it's equal sign. In math, is means equal. 45 is just 45, it's already a symbol. So after you convert every single word to mathematical symbol, you get an equation. Let me put them closer. 150% times X equals 45. So I just need to solve for X here. And first of all, you convert 150% to decimal in order to do that. And as we mentioned before, that means 150 divided by 100. Well, 150 divided by 100. You can either simplify to get a fraction. Or if you know it, whenever you divide a number by 100, it's like moving the decimal point to the left 2 times. So you're going to end up with 1.5. So either way, 15 divided by 10 is also 1.5x equals 45. I don't see anybody who use the fraction. Actually, if you don't want to get decimal, you can use fraction. See, divide by 10, you get 15 over 10. And notice 5 goes into both of them. So you can divide both of them by 5. That gives you 3 over 2. So instead of using 1.5, you may end up with a fractional equation. That also works. We learned how to solve that, right? So either decimal or fractional, both are fine. So now let's divide both sides by 1.5. I think maybe there's 1 or 2 students who made mistakes doing the division. 45 divided by 1.5. If you don't remember how to do that, let me go over that again. 45 divided by 1.5. First of all, you need to move the decimal point to get rid of it in the denominator. So after you move it, you get 15. And 45 doesn't have a decimal. It's considered as 45 as, 45.0. So you can put a dot there and move it to the right. So you get 450. So technically, you're dividing 450 by 15. That gives you 30 because 15 goes into 45 3 times, and 15 goes into that 0 times. So the answer should be 30. Okay, so Sansa made a mistake in the final step. I think I still, as long as you got everything right, I still give you like a half point, partial credit. If you showed your equation was right. This equation, oops, what happened to the equation? Here. Okay, so if you got this equation right and it just made a mistake in the final answer, you get a half point. Okay, so when you take the exam, make sure you write down your steps. And so that in that case, even if you make mistakes, you still get most of minor mistakes like in division or something, because you're not allowed to use a calculator. So if you're not really good with those and made mistakes, as long as you show all the steps, I see you're on the right track. I'll give you most of the points. Okay. All right. So that's the bonus we did last time. They won't be on the first exam, so these will be on the second exam. Now, do you have any questions? So week 5, we still have a assignment this week. So Thursday, we won't have any new lecture. I just go over the practice exam. So the homework assignment this week, I posted on Blackboard already. So I don't know how many I can cover today. Just at the end of the lecture, I will let you know if we need to cross out anything, if we can't finish. So let's look at this week's lectures, 4.2 and 4.3. This assignment, week 5, because it's not going to be on the exam, so I make it due next Thursday, so instead of next Tuesday. So you may have some, if you don't want to worry about the exam now, you want to focus on studying the reviewing, and you can wait until you finish the exam to do this homework assignment. So a week 5 assignment. Okay, so we had one question left from 4.2. That was the interest problem. So let me copy the question here. I'll give you something similar to do. So in real life, we do deal with interest rates a lot. Let's say if you borrow money from the bank, or from credit card company, or if you have money, you will be investing your money and you save your money, you can get interest. So either way, there's something, interest rate is involved. So this is the one on the homework. By the way, I don't know if you remember, if you were not here on Thursday, or you didn't pay attention to that, I did ask everybody to cross out that question in the homework due today, week 4. So you didn't have to do this last time, but you do it this week. Okay. Let's.
Which question was that?
Yes. Huh?
Which question was that? Sorry.
I think it's 62. It was the final question.
Oh, okay. Thank you.
And we didn't have time to cover it, so I just crossed that out. All right. So, but it's gonna be on this week's. So if you wonder, say, oh, I didn't know how to do this, and it's because I crossed it out. We didn't cover it. So now, again, this is section 4.2. Let me mark it here. So this was the homework problem, but I'm going to give you an example very similar. Before that, I'll give you the formula, which for this type of question is called, sorry. Let's see. Interest, how do we find interest? Interest, we take the first letter, I. So there are two things you don't get confused. One is called interest. The other is called interest rate. Interest and interest rate. These are different things. I don't know if everybody knows that. Interest rate, the focus is rate. So when you go to borrow money, the bank will tell you, see, right now the interest rate is pretty low. It's like 3%. If you're going to buy a house, it's probably the best time because the interest rate is really low now, 3%. So whenever you say interest rate, rate is a percentage, like 3% or whatever. So it's some kind of, you have a percentage sign. But interest is different. Interest means dollar amount. It's like, okay, so if I borrow maybe $50,000 from the bank, the interest rate is 3%. How much interest do you have to pay every month or at the end of the year or something like that? So the interest would be a dollar amount. Say you pay $50 per month, or you pay $150 per month. It's going to be a dollar amount. Because in the past, I did have to notice that some students confused them. They didn't know which one to plug in. So remember, interest is a dollar amount. You pay $100, just like your monthly bill. If you have a mortgage, you pay monthly bill, how much you pay, $150 or something. Interest rate is just rate, percentage, it's always percentage. So interest rate, we use R to represent it, first letter of rate. But interest, we use the first letter of interest, which is I. There are two more things. One of them is time. So when you borrow money, the bank usually let you choose. You can, choose 5 years, 10 years, 15 years, 30 years. So there will be time involved. How much time you will be using, you'll be choosing. Of course, the longer time you choose, the less interest you need to pay every month. Okay, so T means time, the first letter. And there's one more thing. I don't know if everybody is familiar with this. It's called a principal. But that's not the principal of school. This principal means kind of like the original amount. Because when you borrow money from the bank, you buy a house, you borrow $50,000. That's called a principal. I don't know if you have a mortgage or you have a loan. Maybe you heard of this. So suppose they tell you to pay $200, which usually includes maybe $150 principal that goes into the money you borrow from. But maybe there's a $50 interest in there. So usually your monthly bill includes two parts. Okay, so principal is the original money you borrow from the bank, credit company. But if you invest money, say you have like $10,000, you want to You don't want to put it in the house. You want to save it, and so you can get a little bit of interest, extra money, right? So the money you save at your bank account to get interest, it's also called a principal. So technically, it's like original money you put in without any interests involved. So we use the first letter P. Okay, so as long as you remember all of these, all the symbols and the formula, when you take the exam, the second exam or final, the formula will be given. How do you find the interest? It's equal to principal times rate times time. That gives you the interest. Okay. In real life, the formula is a little more complicated than this one. This is called a simple interest. Because usually in real life, when we calculate the interest, we don't do it by year. It's not like, okay, you pay at the end of the year how much interest you owe. It's usually by month. So every month you got to pay interest. If you don't pay that interest, well, you will have to pay interest on that interest in the following month, the future. So in real life, the formula is a little more complicated than this. It's a little, it's actually based on this formula. So if you're going to be a accounting major or finance major, you will learn a different version, but that version is based on this. Okay, so this is a simplified version just to make things easier. This is really a lower level math, and so we're considering you're paying a bill like you yearly. Okay, usually that's not true in real life, right? Okay, so I equals PRT. When you do the question, all you have to do is to just plug in numbers for each symbol. But to make a little difference, so I'm just gonna say, okay, I'm gonna just change the numbers a little bit. So I may, how many years must, let's do $10,000 be invested at 3% annual interest to earn maybe to $150. Okay. Usually you may say I guess I'm trying to think a real life situation. Sometimes you may think about retirement to say, okay, how much money? I guess this is a different type. So if I have $10,000, is that good enough for me to retire? So you may be wondering questions like that. So you can save that $10,000 in your bank account, and then you get interest on that. Say maybe the extra interest, you can use it to pay for certain bills. But the question here is how many years does it need? So suppose, okay, I want to get $150 interest, and maybe to buy a certain, like buy a new phone or buy a new computer or something. So, or buy just a furniture, a new piece of furniture. So I don't want to use the $10,000 I have. I just want to use the interest. So how long do I have to keep that in my bank account so I can get $150 interest? So that's sort of like that type of question. Okay, so when we do that, we just plug in numbers, but you do need to know what each number we should plug in for. For example, $10,000. What do I plug that number for? Which one is that? 10 out of these four symbols, which one should be $10,000? Does anybody know?
The principal.
Okay. Yes, thank you. So it's principal, right? Remember, if you didn't know, remember what I said. Principal means the original money you save it in your bank account or you borrow from the bank. So $10,000 in this case is principal, which is P here. So I'm going to replace P with $10,000. Now 3%, percent means interest rate. Or shortly just call it a rate. So R means rate. You're going to put 3% plug 3% in for the rate. Time, we don't know. So I don't know how long I need to keep the money in the bank account so I can get that $150. So if it's unknown, you leave it as unknown T. Well, I is the interest, which is the dollar amount, $150. We plug in for that. So after you plug everything in there, you will get an equation and you solve for t, the variable t. So let's simplify this. 3% means, does everybody know how to convert 3%? So 3% equals a decimal. Do you know? If you know it, you can type in the chatting box.
You would divide by 3, so it'd be 0.3.
Yes, 0. Wait, is that 0.3 or 0.03? Which one did you say?
It's 0.03. You divide by 100.
Yes, that's correct. All right, so you get 0.03. 0.03. If you're not so good with decimals, I guess you can use fractions because 3%, this symbol means out of 100, so you can divide by 100. That also works. So you either use decimal, 0.03, or you can use fraction, 3 over 100. You just have to deal with operations of fractions. Okay, so either way. I guess it's not too bad to use fractions if you really think about it. We already learned how to multiply fractions, so maybe I can try that too. I'll show you both. So if you do fractions, 3 out of 100, you just have to, 100 goes into 1,000 how many times? You cross out 2 zeros here, 2 zeros here, so it's 100 times, and then 3 times 100. So it's not too bad to convert it to use a fraction. But I think most of us are familiar with decimal, so you can use the decimal to do it. 100, and you change it to 0.03, and then you multiply 10,000 with 0.03. And I don't know if everybody knows how to do that. Multiply decimals. The quicker way is you count how many zeros we have. 1, 2, 3, 4, right? So you're going to move the decimal point to the right side 4 times. Because we only have 2 places. Let's add 2 more places so we can move it. 1, 2, 3, 4. You end up with the same answer as we did before, 300. Okay. And the standard way of multiplying decimals should be, I don't know if you remember, that's going to be tested on the first exam. So on Thursday, I will go over that again if you forgot. So you ignore the decimal point. So 0.03 is just like 3. You do 3 times 10,000. That's going to give you 30,000. And then you put the decimal point back. There are 2 decimal places. So you're going to put 2 decimal places here. You still get 300. Okay. So if you didn't know the quick way. Anyway, so after you multiply, then either you use the fraction or decimal, you should get 300 here and 150 there. Now, what do I do to get rid of, to get t by itself?
You divide 300 on both sides.
Yes, very good. Okay. Sometimes I saw students who divide both sides by 150 because we're so used to the variable on the left-hand side. But if you divide by 150, you got rid of 150. But our goal is not to get rid of 150. We want to get rid of 300, right? So be careful with that. So you need to divide both sides by 300. 300. So you can get t by itself. Okay, so after you divide both sides by 300, 150 divided by 300, you can either use decimal or fractions. Fractions are probably not too bad to do in this case because 150 divided by 300, first you can divide both of them by 10. That gives you 15 over 30. And 15, notice that goes into both of them. So you can divide both of them by 15. That gives you 1 over 2. So how much time do we have? 1/2 year. 1/2 year, 6 months. 6 months, right? So you can either use 1/2 or decimal, which would be 0.5. Either answer is acceptable. Okay. So how much time do you? So it means, okay, you just need to keep the $10,000 in your bank account for 6 months. You can get $150. And you can take the interest out to buy something you want, right? And that's how much time you have to wait to buy your new furniture. Okay, so that's a simple question of this type. But I could change the question to other things. For example, sometimes I think, oh, how much money do I have so I can retire? So maybe what I wanted to do in this case would be I equals P RT. So I'm looking for principal. And so suppose say maybe you want to keep the principal in your bank account, not to touch the principal. You just want to take out the interest every month so you can use it for monthly expenses. And you will, even if there's some emergency, you still have principal in your bank account for the emergency. So in that case, let's say every month you need $1,500 to spend $1,500, and the interest rate maybe it's 3%, and the time is maybe excuse me, 1 year. We use 1 year. Every year, how much interest can you get? I guess, sorry, that would be for maybe say 1 year. Then the interest would be 1 year. So 1 year, suppose every year you spend $15,000. That's the minimum you need to cover your utilities and other things, food, and so how much money do I have to save, and so I can retire? So this in this case will be asking for principal, interest, because you want to use that interest to cover your expenses. So how much money do you need to have? So we can kind of do that workout. So I need to save 15,000. So I want to get this much interest every year. How much money do I need to save? Rate is 0.03. It's 1 year. I'm talking about 1 year. And so simplify this, you will get 15,000 equals 0.03 times 1 will still be 0.03. So you divide both sides by 0.03 to get rid of that. And to move the decimal point, this is how to divide the decimals. So you can see why in the previous section we learned how to multiply, divide, add, subtract decimals, because for this section we do need to use that. And in real life we do need those too. So you can move the decimal point to the right 2 times to get rid of decimal point. All right, so you're gonna get 1500000 divided by 3. After you move the decimal point, the bottom doesn't have decimal point anymore, so you can divide them to give you 500,000. So that's like $500,000, and that's a lot of money. So it's like $500,000, and you can see it's kind of hard for us to save that much money, and just gives you $15,000 interest. Okay, and excuse me. And there could be other questions. So in the first example, like in the homework, it's asking you solve for time. So how much, okay, so we're asking, we know interest, we know principal, we know rate, we ask for the time. But in the next question I did was, I know interest, I know rate, I know the time, I just don't know how much I need to save. And there could be other ones. So I may ask for interest rate, or I may ask you for the interest. Okay, and so that's whatever that is. You just plug in numbers and to get what you need. Okay, so that's the first question. It's like a leftover question for section 4.3. All right, any question for this? Okay, so if not, we're gonna look at the 4.3. So 4.3, we're gonna solve equations involving like decimals. Let's excuse me. If you have you can bring up the homework to look at the problems, what type of questions they are. 4.3. more on percents and problem solving. So we talked about a percentage in 4.2, but here we're gonna just have more. Before we look at the problems, word problems, real life problems, we're gonna look at how to solve equations. We kind of did that already, like this one. Where was it? Yeah, like this one. It has decimals in there or percent in this equation. As you can see this one has percent in the equation. So we're just going to have some more examples here in this section. Example 1. Suppose we have x equals 4.8 minus 0. And I can also do 2 decimal. 0.2, maybe 25x. We did similar question before, but without decimals in there. Like the problems on the first exam, practice exam, we had questions like this, but we all only have whole numbers, right? Or, we may have fractions, but we didn't have a lot of decimals. So how do we get x by itself? The steps will be the same as before. Any idea how to solve for x?
Divide 0.25 on both sides.
You said, wait.
Did you say divide?
Yeah, I did.
You're going to actually add 0.25.
Yes, add, not divide. Okay, I think you're saying divide, and probably because you're thinking, I have a multiplication here. That's why I have to divide it. But we're not trying to get rid of 0.25, right? We're trying to get rid of 0.25x, the entire thing. And in front of it, it's minus. So the opposite of minus will be plus. That's right. It should, who was that? Corrected Melissa?
Amanda.
Amanda, okay. I need to bring up the other one so I can see who's talking. Okay, so we can add 0.25 to both sides. So we're getting rid of the entire thing, or it's equivalent to moving this to the left-hand side. And that's one of the steps that we talked about before. How to solve equations. Do I have? Yeah, I still have the steps here. I can show you a little quick here. So if you have, if we have, enlarge this. If we have parentheses, we got to get rid of parentheses by distributing the number in front of parentheses. We didn't have any in that example. Combine like terms as much as possible. And we didn't have like terms on each side either, so we didn't have to do step 2. That's what we just did. It was step 3. We move all the terms with the variables to one side. Yeah, move all the terms with the variables to one side. So that's what we did. Go back to that. Okay, so we have x on the left, 0.25x on the right. We have to move one of them to the other so we can combine them. In order to move something, or you are trying to get rid of it from one side, you can do opposite operations. Okay, so after these two, of course, cancel each other because 0.25 minus 0.25 is 0, and 0x is 0. But how do we add them? How do we combine them?
Those we just add to 1.25x.
Yes, thanks, Melissa. I don't know if everybody can see that like Melissa did. X, there's not a number in front of it. There's actually 1x. And if you think about it, it makes sense. X means one copy of x, right? So x is equal to 1x. Okay. Well, usually if there's 1 in front of it, we don't write it. Automatically, we know it's 1. So it's like 1 plus 0.25, and 1 plus 0.25 You know, 1 doesn't have a decimal. It's at you put it at the end, so it's like 1.25x. And you bring down at 4.8. Now we're gonna divide both sides. Now we can divide because this time I just want to get rid of 1.25. So the difference between what Molly? What do you mean turn into exponent? I didn't understand what you.
Can you hear me?
Yes, I can.
In my head, I had a little brain fart, and I thought that when you added those two, it turned into 1.25x.
Oh, yeah,
for some reason.
that's actually multiplication. We did. Have we talked about multiplication yet? Well, I think we did a little bit, have we? Later
You
in
did. It just slipped my mind.
Yeah, later later chapters we will talk about multiplication again. So if we have x, say x times 0.25x, so x times x will give us x squared. But here we're not doing multiplication, we're doing addition. So when you do addition, you won't get x squared. When we do addition, first of all, we have to make sure they're like terms. For example, x and x, and you will still get x, okay? What I usually say is, think of this x as a dollar sign. So it's sort of like $1 plus $0.25, you're still gonna get dollar, you won't get dollar squared. Okay, so the time we will get squared is when you do x times x, that gives you x squared, x plus x, you don't get x squared. This little 2 actually is in front of x. You get 2x. Like I said, think of it as a dollar sign. When you do addition, $1 plus $1, you get $2. You won't get dollar squared. Okay, so these are something we would talk about this more later. Okay, so when we get here, 1.25x, we divide both sides by 1.25 to get rid of it. So the biggest difference between the two operations we did here was, when we did it here, we want to get rid of 0.25x, the whole thing highlighted. But right here, I don't want to get rid of x. I just want to get rid of 1.25. And between 1.25 and x, that's multiplication. So I do opposite of multiplication, which is division. But over here, I wanted to get rid of the whole thing. And in front of the whole term, it's minus. That's why we did a plus. So that's the difference here. So now the next part is 1.25 cancels 1.25. I get x. And for that part, we do need to work it out. So the 4.8 divided by 1.25. The first thing we want to do is to get rid of the decimal in the denominator divisor. So we're going to move it 1, 2 times. Move it 1, 2 times. So you pretty much dividing 480 divided by 125. See, there's another option. If you don't like long division, you can just keep your answer as a fraction. So maybe you could just reduce this as a fraction, because 5 goes into both of them, so I can divide both top and bottom by 5. And that gives me 25, and this gives me 96. And now let's look. The only number that can go into 25 would be 5, but 5 doesn't go into 96. So that tells me this fraction is already reduced. You can leave your answer as a fraction. The other option is to divide them, do long division. Okay, so 125 goes into 480 how many times? 2 times would be 250. 3 times would be, let's try it, 375. Let's subtract them, see if we can get it. See what we get. That'd be 105, and which is smaller than 125. We can use 3 and can continue to add a dot and a 0 to bring down to get some decimals. So 125 goes 1050. I think it's 8 times. 5 times 8 is 40. 2 times 8 is 16. So that gives us exactly 1000. And subtracting again, we add 1 more, and that gives us exactly 2 times. Wait, hold on, that's not 2 times, sorry. 3. Again, 3. 125. Oh, that's 4. All right, so yeah, it's exactly 4 times. Sorry. Erase this. So 125 goes into 500. Exactly 5 times. If you did long division, you're gonna get 3.85 as an answer. Okay, but both are acceptable. I think probably reducing a fraction is easier. As you can see, all I did was dividing both numbers by 5, right? But if you do long division, it takes you quite a bit of time because you have to keep going until you get a remainder 0, or maybe if you found out maybe you have to do 2 digits, so you round it. So probably a fraction is not too bad, right? Okay, but anyway, either answer is acceptable. Any question about this example? Okay. Now, I'm going to show you a different way to do this. If you don't like dealing with decimals, there is another option. Previously, I didn't mention when you have fractions, you do have to get rid of fractions. Wait, did we talk about this already? Kind of the other way. So let me show you here. X, 4.x, 4.8 minus 0.25x. Does anyone know, like, if I don't like fractions, I want to get, so decimals, I want to get rid of all the decimals in the equation. Is there any other way to do that? Does anybody know?
Multiply both sides by 100.
Yes, very good, Melissa. So that's a different option. You can, if I can show you, and you can pick the way you like. So if you say, well, this is not too bad, keeping all the fractions, I know how to add fractions, divide fractions. But for some students said, I don't like dealing with decimals. I'm sorry, did I say fractions? I mean decimals. So if you don't like dealing with decimals, and you can do what Melissa said, you can multiply both sides of equation by 100. The reason we can do that is normally when if like on this practice exam or on the real exam, if I give you a question like this, I ask you to multiply I ask you to divide 4.8 by 1.25. You do have to divide them. You cannot just say, let's multiply both number, or I guess division, you can move the decimal point, but if it's multiplication, you kind of have to multiply them. And so you won't be able to change the numbers. You can ignore them and put them back. But with the equation, one of the properties we learned before, whenever you have an equation, okay, so you can add a number, subtract a number, multiply a number, divide a number, as long as you do it to both sides. For example, you have 3 and 3, you can multiply both sides by 2 to change 3 to 6. The numbers are changed. See, originally we have 3, 3, but now we have 6, 6. So the relation doesn't change. They're still equal to each other. So we can do the same thing. We can multiply both sides by 100. The reason Melissa chose 100. Melissa, can you explain why you chose 100, not 10?
Yeah, there's 2 decimal points at the most. The one has 1, that
Yes.
one has 2, so you need 2 zeros.
Yes, so it looks like you learned this before, huh?
Actually,
so-
I got this view the other day. I'd never learned it before.
Oh, so we already talked about this, I guess. All right.
Well, we did with the fraction, so that's what I was assuming. Like, I think. I don't know.
All right, great. Actually, very, very good. Because I did talk about this in 1200 because I teach another class, but I don't remember if we have covered this in this class or not. Okay. In 12, if you're going to take 1200 next semester, you're going to do this again. But the equations you get will be much more complicated, but the idea is the same though. Okay, so exactly what like Melissa said. When you have fractions, you multiply by LCD to get rid of all the fractions. When you have decimals, you can multiply something to get rid of decimals. But the difference is, for decimals, in order to get rid of decimal, you just move the decimal point, right? When you move decimal point, change it from 0.25 to 25, it's equivalent to multiplying 100. So when you have two decimal places, you need 2 zeros. So you can move it to the right 2 times. So that's why you, I guess that's exactly what Melissa did. You look at how many decimal places you have in each number. So 1 here, 2 here. So you need to have multiply 100. So you can get rid of decimal places in both numbers. If you only multiply by 10, 10 times 4.8 will give you 48. But 10 times 0.25, so there's only 1 zero that can only move the decimal point to the right 1 time. That just gives you 2.5. It still has decimal. So that's why we always choose the bigger one. So go back to 100. So that's how we pick the number to multiply. It's always going to be multiples of 10, either 10 or 100 or 1,000, depending on how many decimal places you have. If you have 2 zeros, so it's going to be 100. Now let's multiply them. So what is 100 times 4.8? What will that give you?
480.
Yes, 480. The quicker way is to move the decimal point. So you do 1 and 2. So that gives you 480. And 100 times 0.25, if you move it to the right 2 times, it gives you 25. So now look at this new equation. No decimals anymore. All whole numbers. The number's kind of big, but at least you get rid of decimals. So now all you have to do is add 25 to both sides. Remember, this is very similar to the one we did before, but we are adding 0.25x. And there might be a little bit confusion here. How do I add x and 0.25x, right? But when you change it into whole numbers, it should be much easier. So you just do 100 plus 25. That gives you 125x. And that cancels each other. So you get this immediately. So you divide both sides by 125. So if you like this new way better, you can always do the new way. I'm going to just reduce the fraction. 96 over 25. Okay. But if you say, well, the decimals don't bother me, you can just do the old way, keeping all the decimals. Okay, whichever way you like. Let's look at another example. I'm going to make the equation a little longer than the first one. Let's see. All right. So we're going to put a parenthesis in there. We did do this before, this type of question before. So with the parenthesis, we know how to deal with that. So 0.10, it's pretty much 0.1 x plus 0.21 plus 0.12 times x plus 1,000. Oh, in the homework is minus, right? Maybe I can also do that. Let me do something similar to the homework problem. So I can do 1,000 minus x equals 560. Okay, so first thing we're gonna do is to get rid of parentheses. Distribute. Well, I guess the other option is, there are two options. You either keep all the decimals or you get rid of decimals. Maybe I can do both ways, but two different ways. So first, I'm gonna keep all the decimals. So I'm gonna keep 0.1x. 0.12 times 1,000. There are 3 zeros, so that means you move the decimal point to the right 3 times. Okay, because I only have 2 places, right? So I'm going to add a 0 so I can move it 3 times. 1, 2, 3. That gives me 120 minus 0.12 times x. Okay, distribute that. Equals 560. So that's the first step, getting rid of parentheses. Second step, combining like terms on each side as much as possible. So let's combine them. You can kind of try to work it out, see if you what answer you can get. 0.1 minus 0.12. If you find the answer, type in the chatting box. 0.1 minus 0.12. What can we get?
Is it going to be 22x? Is
Oh,
zero, or
I
is it going to be point?
I have all the decimals. I didn't get rid of decimals.
Right, it's going to be point. Actually,
might be a little hard to do with the decimals. So probably.
well, it's probably. I would say 0.22x.
Actually, 0.0.
Oh no, yeah, 0.
And also it's
Right.
negative. Okay.
Negative.
Yes, negative. Oh, I see so many different answers now. Okay, so it looks like decimals do confuse us sometimes. So probably we
I don't
should.
know if it's so much the decimals, but it's where it's kind of you put the minus.
Right. I mean, that's what the problem is. So we just have to kind of deal with that, because that's the minus given in the problem. We cannot change it right? I think I'm going to do the other way later. You can compare. I think it's what if I give you this and will this make it better? It's calling me. So let me give you this. Are you able to combine 10x minus 12x? What's 10 minus 12? Will that make it easier?
2. Negative.
Huh?
2. Negative 2.
Yes, it's easier, right? Okay, so it looks like, I think it is the decimal. So how do we do 0.1 minus 0.12? Okay, let's write it. Maybe I get a new page here. So how do we do 0.1 minus 0.12? When you look at them, actually 0.12 is bigger than 0.1, right? So you're subtracting a bigger number from the small number. First thing you have to kind of compare them. Oh, this one is bigger than that. So you're going to have to flip them, sort of like doing this, 0.1 to minus 0.1, but with so you're going to get 0.02. But because you're subtracting a bigger number from the smaller number, you're going to end up a negative 0.02. Okay, so dealing with subtracting decimals, a bigger one from the smaller one, sometimes does confuse us. You kind of switch them. So this is like doing 0.1 plus, you can put a plus sign there, negative 0.12. Suppose you have 0.1 means like you have 10 cents. If you have 10 cents, but you spend 12 cents, okay, sort of like if you think that way, it'd be easier. But with the decimal form, it's a little harder to do. Okay, so the correct answer after you subtract them, you should get point. Melissa, you were almost right, except I think you missed the minus sign. So it's 0.02x. Okay. And the plus 120 equals 550. Okay, so for those of you, if the decimals confuse you, maybe you should change it into whole numbers to do the whole numbers. Okay, so after that, you subtract the 120. Can move a little faster because that's what we did before. So you get negative 0.02x equals 440. Subtract them, 440, and then you divide both sides by negative 0.02, and that gives you. First of all, determine the sign. Positive divided by negative, that gives us negative. Next, we divide the decimals. Move the decimal point to the right 2 times. Move the decimal to the right 2 times. So you get 44,000 divided by 2, which gives us 22000. Okay, 22,000 as our answer. I guess the tricky part is right here. How do we subtract 0.12 from 0.1? You end up with a negative 0.02. Okay, so let's look at the other way to do it. So the other way will be what Melissa said before. We can multiply both sides by multiples of 10. We have 0.12 here. Okay. And 1 decimal place here, 2 decimal places here, which means we need 100. So let's multiply 100 here. I use black. 100 here. Oops. Multiply by 100, multiply by 100, and multiply by 100. Okay. Now, 0.1 times 100, that gives you 10x. And 0.12 times 100, 12. We're going to keep the parentheses. On the right side, 560 times 100, 560, 0, 0. So you're going to get big numbers, but you don't have to deal with decimal. After that, you distribute 12. That's why you should get in this step. So 10x, 10x, 12 times 1,000 is 12,000. 12 times negative x, it's negative 12x. 56,000, 56,000. So now instead of combining these two like terms, the decimals, you will be combining 10x minus 12x, which is negative 2x. Because we are familiar with dealing with 10 minus 12, the integers instead of decimals. So it's much easier to do this way. Okay, and now we get rid of 12,000 from both sides. Okay, negative 2x equals 44,000. And you can divide both sides by negative 2. All right, so we got negative 22,000. Okay. All right. Any question? Okay. So maybe when you can try to, if the problem is not too bad, addition probably adding decimals is easier. But subtracting decimals, especially when you subtract the smaller, a big one from the smaller one, that could confuse you. So in that case, you probably should do the new way to get rid of all the decimal, change it into whole numbers, and that would be easier to do. Okay. Do you need more examples for this? Okay. Brandy, you need more examples? So I can do another one, a little quick. Let's see. So let's try one more example for this type. I'll do 0.08 plus 0.11. 500 minus x equals 50.5. Okay. Let's try to keep the decimal for now, see if you have trouble. So first I'm going to distribute that, and 0.11 times 500. Remember when we multiply decimals, you ignore the decimal point. So it's like doing 11 times 500. 11 times 500, that gives you 5,500. Now let's put decimal point back 2 decimal places. So you can end up with 55 here. And then we have to distribute 0.11 to x. That gives you 0.11x. All right. Now here again, oh.
Is that 50.5?
55, 50.5, 50.5. Yes, it is 50.5 on the right side. Sorry about the writing. I'm sorry, I missed the x here. Sorry. Right here, there's x. When I copy the question down, I missed the x right here. Now, here's the same type of question. Can you combine 0.0? Let me fix the writing a little better. Can you combine 0.08x and 0.11x? Can you subtract this from that?
Yeah, you can subtract the 55 and the 0.8. Wait, no. Yeah, you can subtract those. And you would
so
get 0.
Can you
it would be a
the-
negative 0.3.
Yes, that's right. Is that Amanda? What, Melissa? Amanda? Okay. All right. So if you can do that, maybe you can do the old way. Okay. But if anybody gets confused right here, how do I subtract 0.11 from 0.08? Maybe you can just get rid of them from this step. Okay. So when you get here, say, oh, I'm confused. I don't know how to subtract 0.11 from 0.08. So you can choose to multiply 100 here. You don't have to multiply 100 from the first step, any step, anywhere, as long, you know, as it's convenient. So I'm going to just multiply 100 here. And 100 times 0.8, I get 8. 100 times 55, I get 5,500. And 100 times 0.11, I get 11, negative 11x. And then 2 places, add a 0. So you get 5050. So you're just going to be doing 8 minus 11, which should be easier than 0.08 minus 0.11, right? Okay. But like Melissa, if you say I can do that way, you can keep all the decimals and continue from there. Okay. But for those of you, if you get confused, I don't know how to subtract the decimals and a big one. Actually, you have to switch them. Okay, to do 0.11 minus 0.08, so it gives you 0.03, but it's going to be negative when you subtract the bigger from the smaller. Okay. So in this case, I just do 8x minus 3. 11x gives me negative 3x. And next, I'm going to try to get rid of that 5,500. Okay, negative 3x equals. Now, when you subtract 5,500 from 5,050, it's also doing subtracting a big number from smaller. So you have to flip them. When you subtract them, you got to do 5,500 minus 5050, but you put a minus sign in front of it, because suppose you only have $5,000, but you spend 5,500, and you're going to end up negative. How much did we overspend? That's negative 450. So you're going to actually subtract the back way and put a minus in front of it. Okay, now let's divide both sides by negative 3. And that gives us x equals, negative divided by negative will be positive. 450 divided by 3, that's going to be 150. Okay. If you cannot see that, do long division. When you take the exam, I will not give you like really big numbers. Takes you so much time to do. Just going to be very small numbers. Okay. All right. So that's another example for that. Okay. Now let's move on to the next question. It's a word problem. Let's see. Yeah, so I don't, yeah, probably, let's see. Okay.
Okay.
Yes.
I just have one question. So that is the second way, correct?
Yes, the second way. I got rid of decimals.
Okay. But if we do it fine the other way, we don't have to do it this way, right?
Right. Yes.
Because this is too busy for me.
Too busy?
Yeah.
Oh, okay. So if you can deal with the decimals, that's fine.
Okay.
But just make sure you don't make mistakes with the decimals. Okay. So maybe I can go ahead and finish the other way. So if you didn't do this way, what you have will be negative, as I think was that Melissa or had one Amanda, negative 0.03x plus 55. I don't want to mess with all that. So let me put it down here. You're going to have negative 0.03x plus 55 equals 50.5. And you subtract both sides by 55 instead of, bigger numbers like that. So you get negative 0.03x equals negative, that would be 4.5. Okay, and then you divide both sides by negative 0.03, negative 0.03. You should get exactly the same answer, 150. Okay, because in this case, you got to move the decimal point to, it's like doing 450 divided by 3, exactly the same way here. Okay, so that's the keeping the decimals or getting rid of decimals, 2 options you have. Okay, any other question? So now the next one we're gonna do, it's a word problem. If you look at the problem on the homework, it says, so somebody's gonna sell some video games that cost her $25 each. She wants to sell them at a profit of 80% of the cost. What price should she charge for the video games? Okay, I mean, nowadays everybody can sell things, and you can sell it on eBay, Amazon, and so sometimes you might need to determine the sale price. So there will be two different prices. One is the cost. So you buy something from somebody, it costs you this much money, and then so this is the cost. And then you want to sell it again to make money, of course, and you have a sale price. You need to determine, okay, how much should I sell this for? And usually you have a goal in your mind because you want to cover, the shipping, the time you spend on, and all those things, right? So you want to make sure the profit that you're gonna make is worth it, right? If you just make like a very little money, and you probably don't think it's worth it. So you decide that whatever the sale price is, it will guarantee you're gonna make a profit, and this profit is going to be. So I'm gonna just write on the sentence: the profit is 80% of the cost. Okay. All right, so that's the sentence given to tell you how much profit it's gonna be. Well, I'm gonna do something similar. So how about I gonna change the cost? In the homework, it's $25. I'm gonna change it to maybe $15 each, and sell as a profit of 80% of cost. I'm just gonna change it to maybe, oops, I can change it to let's do 60% of the cost. So what will be the sale price? So there are two things given. First of all, the cost. So you buy something, you know it. Okay, I bought something for $15 each, and I want to make a profit of how much? 60% of the cost. So the cost right here is the cost that you paid for, $15. And the question, sale price. Let me move this question here. Just start with. Okay, the question is selling price equals how much? Okay, so we are going to translate this sentence to from words to symbols. So profit, I'm just going to write down profit, P, maybe. You can use, just write on the word profit, is the equal sign. 60%, it's 60%. Of means multiplication. The cost, it's $15. So I plug everything in there. Okay, so now I'm going to work this out. 15 times 60%, which gives us 0.6. 60% is 0.6 times 15. Now, when you multiply decimal, ignore the decimal point. So just multiply 15 times 6. That gives you 80. 90. And now put decimal point back. One decimal place. So that's pretty much $9. So which means for a $15 product, you want to make $9 of it, and because that's gonna that's be the profit you're gonna make, the money you're gonna make out of each, and because that's gonna cover your shipping, cover maybe the time you spend on that and all that, like supplies and maybe internet and everything. Okay, so how much should you sell it for? The selling price should be equal to the money you paid for each product, $15, plus the profit you want to make, right? So cost is $15 each, plus you want to make $9 out of it. So that together you should make the selling price $24. Okay, so that $24 will not only cover the cost that you have, but also make you a $9. Okay, all right, so that's an example similar to your homework question. I didn't give you one with, in this case, you may see, well, I didn't have any equation, right? But the idea we use is converting words to symbols. In some cases, you might end up with the equation that you have to solve an equation. I'll give you example, although there's not one in the homework to do, but I'll show you an example here. Okay, so this is example in the textbook. Suppose you bought a dress for you bought a dress for 30% discount. 30%, a dress is on sale, 30% discount. Okay. After discount, you noticed, so they tell you, okay, it's $35. So after discount, that's the money you pay. You actually pay. You pay $35. Okay. To make things a little easier for us, let's not worry about tax. We know we buy things, we need to pay tax. But I think in Oregon, you don't have to pay tax, right? So in some places, when you buy clothes, a dress, you don't have to pay tax on that. Okay, so let's just not to worry about the tax. So the question is, how much is the original price? Question, original price before discount. Well, maybe call it before discount. Okay, suppose that, I mean, usually the tag would probably tell you, say the original price, and after discount you pay this much. But suppose you missed that original price, and so you're trying to tell your friends, say, oh, I bought something, the original price is this much, I only paid $35 on that, so you saved a lot of money. But suppose you didn't, the tag is missing, you don't really know how much your original was, but you got a 30% discount, so you're trying to figure out, okay, how much was the original? So that type of question. So in this case, you can use the equation to do that. Okay, so apparently the price you paid after discount is the original price, or the price before discount. Let me just call it original price. Original price minus discount. Money you saved. You saved this much money. But the problem is we don't really know how much money we saved, right? So this is the after discount price. After discount price, $35 is equal to original minus discount. Okay, so I do know after discount, I paid $35. So for that equals original, which is unknown. I don't know how much that is. So let's call it X minus discount. Well, I don't know the discount either, but I do know we get a 30% discount of original. Whenever we say the discount, it's always of original. So the extra discount, the dollar discount you get is, so the discount we get is going to be 30% times, of means times, right? Times original. So 30% would just be 30%. Of means times original, I don't know, which is X. Okay, so that gives me a discount, which is 30% times X. So now you end up with the equation that you got to solve for X. This is similar to the equation that I gave you before. We solved before, like this one. Okay, so sort of like this question we did. Okay, and we know how to solve for X. This equation right here. The way we do is we can just convert 30% to decimal, which is 0.3x, and then we can, in this case, we can just combine them. 1x minus 0.3x, that gives you 0.7x on the right-hand side. Combine like terms on the right side, and then divide both sides by 0.7. So divide by 0.7, divide by 0.7. So that should give us, move the decimal point to the right one place. So you get 350 divided by 7, that's $70. Oh, sorry, $50.
Yeah.
Okay, so okay, original price is 50, I only paid 35, so I saved $15. It's sort of like that, okay? Let me, this is a little messy, so let me rewrite it. This is like, my thinking process. So when you actually do the problem, for one thing is what we need to know is, so the price we paid, or price after discount is equal to the original price minus the discount price, how much money you saved. But discount, where do we get discount? Discount is always equal to, in this case, discount is 30% of original. So when you walk into the store, they say 30% off, which means 30% of original price. Okay, so that's how you get your discount. So now let's plug in everything. So price after discount, that's what you pay at the cashier's, at the checkout place, $35. That's what you paid. Equal will be equal. Original price is unknown, right? So let's keep it at X. Minus will be minus. Well, discount, how much is discount? Discount is 30% of original. So you're going to use that expression here. So 30%, it will be 30% of, it's multiplication, original is X. We just use X for original. So that's how you get the equation. Okay, so you will write down this and you plug in numbers. And the rest of it will be the one we just did, minus 0.3x. And so you're going to get 35 equals 0.7x, and divide both sides by 0.7. Okay, so you will have 35 divided by 0.7, which is, move the decimal point to the right one place. So you end up with 350 divided by 7. That gives you 50 as an answer. Okay, so I didn't give you this one on the homework. I figured it might be a little harder, a little maybe too difficult for some students. And in your 1200, if you're going to take a 1200, you're going to have problems like this. Okay, but in this class, I made it a little easier, and so you would just be if you are able to do this problem here. So you don't have an equation, just plug in, and you can get numbers, a basic math question. All right, looks like I'm running out of time, so you can cross out 4.4 on the homework. Well, I will just maybe update that if you haven't printed out. So let me show you here. Because I didn't know how much I could cover, and so I actually put 4.4 there. Let me show you. If you already printed it out, just cross out you don't need a second page. So the problems on 4.4, we will talk about these questions after the exam next Thursday. So no class next Tuesday, so you don't have to do this. I will get rid of them, maybe put a new updated version there. So you only have to do these 1, 2, 3, 4 problems this week. Okay. Any question before the bonus? All right, now let's do the bonus for today. Yes.
I wanted to ask
if
we are submitting the practice exam
today.
Yes.
Yes, yeah, it's due today. The latest time you can turn in will be maybe tomorrow, or the thing is on Thursday, I will give you all the correct solutions. So which means you cannot submit your practice exam after Thursday's class, because all the solutions are given, and so you won't be able to just copy my solutions and submit. So as long as you turn in before that, and you will be fine. Okay. So probably I can waive the late points this time for the bonus of for the practice exam. Okay. But again, you cannot submit after that. You won't be accepted after that. Okay. But homework, if you turn in late, you will lose 2 points each day. But just for practice exam, because of that, because I give out solutions, so you cannot turn in too late. Okay. Other questions? So today you have 2 assignments due. One is the practice exam, one is the homework, week 4 homework. But like I said, you could get a 1-day extension if you haven't finished the practice exam yet. Okay. So let's see. We have this is week. Okay, so the first one. Okay. So one question will be that the formula we learned to calculate interest. So let me write down the question here. Find the annual interest rate. Okay, so it's looking for the rate. If $560 in interest is earned when 3,500 was invested for 2 years. Okay, I'll give you the formula here. It's I equals P times R times T. Okay, so you just make sure you plug in the right numbers. Okay, so remember this is the one you're looking for, which is the rate. Okay. Now the second problem will be that decimals. Okay, so you
That
can.
says 560, correct?
Yes, 560.
Okay.
560, 3,500 here. Okay, so the second question is 0.08x equals 580 minus 0.1. Okay.
We can't hear you.
Sorry, I was not. I'm not saying anything. Okay, I was just talking to my husband here. Yeah, just wait. How much do you need? 80 plus 100?
Well, do you want me to use those ones?
Yeah, why not? Just
So then it'd be
split them.
130.
Yeah, 130.
Can I ask a simple question really quick?
Sure.
It sounds silly, but I got it wrong on the thing, and for some reason I have, it's the littlest thing, the R divided by whatever question, and I did them backwards. Is there any way to remember like which, like I think it was like write the equation R divided by D or something, and I did it the wrong way. Like is there a way to figure that out? Like maybe I should just know it, but I mix that even with fractions sometimes. If it's a bigger number, I always forget which number like to divide by, like which way to swap them.
Give me an example. I'm not sure if I'm following. Are you talking about when you solve equations? Is that what you're talking about?
It was on homework 3, I think. It was,
Oh.
I mean, it was easy. It was translate the word.
Oh, I know which one. Okay, yes,
It
I
was
can.
R divided into D, and I put R over D, and I don't. But I confuse that sometimes even with numbers, like when I'm dividing, I don't know which one I'm dividing into which. I don't know why, but I just
Actually,
do.
yeah, I mean, I understand that. I mean, it's there are two things. Yeah, there are two things. One is called divided by, one is called divided into. Okay, so these are different. These are opposite. Just like hold on, let me. I don't know if everybody got the problem written down. Okay, so for those students, if you can do these two questions and you can just maybe mute the microphone or if you want to leave the meeting. So because the question Melissa asked is not really related to this bonus here. So, okay. Has everybody copied down the problem yet? So maybe I can get a new page. Okay. So if you haven't, if you need the problem, just let me know. I'll just get a new page for you. So these are two different things. I guess it's sort of like memorizing it, but there's a way. So for example, R is, if I say divided by D, or R is divided into D. So the difference is by and into. Okay. So these are reversed. I don't know if you know which one is which now or.
No, like not, I never even thought about there being a by and into, like I just all figured it was the R over D. Like, I don't know.
Same
Like,
way.
but you always teach me like little ways I never learned. So,
Okay.
so I'd like to know because it's a simple mistake I shouldn't be making. So,
Into, you know, into means goes in there, right? So I don't know if you heard of things like, okay, we say 6 goes into 18. You understand? The 6 goes into 18 like 3 times, right? We do say that. So whenever you say goes into, it means 18 divided by 6. 6 is into 18. Okay. So
Okay.
into, yeah. So maybe, I don't know if that helps you a little bit. So it's kind of like you can put the numbers in there to help you. So if I say 6 is go divided into or goes into 18, you got to do 18 divided by 6. So it's kind of like, backwards. Okay. But when you say R is divided by 6, if it's by, it's just following it. Okay. So that would be following the order. R is divided by D. Okay. But when you say into, you got to reverse then. Does it make sense?
yes, yes,
Okay.
very much so. That helps a lot.
Right.
Thank you.
Yeah, it's a little tricky.
Yeah.
Different words.
Yeah, I said I never, like I said, you teach all kinds of little tricks I never learned before, and it makes it so much easier. But for some reason, I don't know, I've always had an issue with it, but that explains it. I've never even noticed the difference of the two words. So thank you.
Yeah. Yeah, no problem. You're welcome. Molly, yes.
Can you hear me?
Yes, I can.
So the last problem you were explaining, how you were explaining like the discount thing, finding like the original price.
Mm-hmm.
So, okay, little story time. When I went to community college before this, I took an entire business math class. I don't know why I didn't transfer, but I learned a lot quicker way to do that doesn't involve variables at all. I didn't want to say it because I didn't want to confuse people. It was just another one of those little observations.
Mm-hmm.
Pretty much what I'm saying is like, I mean, in my head, I know that the original is just the discount divided by like
70%. Is that right?
Subtract the discount from 100. Subtract the discount from 100 and
Mm-hmm.
divide the discounted price by that by the difference.
Yes.
If that makes any sense. So,
that's fine.
is it okay
Actually,
to do it without variables?
yes, it is okay to do that. See, there are actually a lot of questions that you may not even need to use algebra to do it, and algebra just gives you a different way to do the problem. So if you already know to do it, how to do it, say I just know divide by 70%. Okay, so just take, just take the that the price 35 divided by 70%. This is correct. I mean, if you know that, great. Okay. Algebra, yes, you can do that way, certainly. Algebra just provides a straightforward way, so you don't have to think. Because a lot of it's actually it might seem to be easy to you, Molly, but it's actually difficult problem for a lot of students. When they look at this, they don't really know what to do. Do I do 35 times 30% or divide by 30%, or what do I do? So a lot of students, they don't know that, and so that's the way, which gives you a possible way that you don't have to think. Do I do division? What multiplication? It just translates everything into equation, and then you just solve it. Okay. But okay, great. If you know,
Alright.
the other way, that's fine. Certainly fine. Yeah.
Yeah, I purposely didn't point that out because I didn't want to confuse people, but I was just checking to see if we had to do the algebra. But if not, that's great.
Yeah. Do you need to take 1200 or not? Oh, yes, you do, right? Did you mention that?
I do have to take 1200.
Okay.
But yeah,
So
I
in
did. I couldn't. My advisor never got back. So.
Oh, what? Wait, did I ask you? I forgot. What's your major?
Applied nutrition. I'm majoring in dietetics.
Okay. Yeah. So I guess you do. Well, in 1200, usually the equations we're going to solve, the word problems we're going to solve are much harder. And in those cases, using equations might be easier. You, I guess usually if you're engineering major, you would be solving very complicated question using equations would make things much easier to do. So usually we learn this, so when for those, especially for engineering students, it would be useful. Okay, but a lot of if you're not going to be solving very difficult problems like that, basic math probably will work.
Okay, I got you. All right.
Hey.
Well, thank you.
You're welcome. Hey, Molly, did you check with the? I guess whoever is in charge of the placement? Did you? I don't know.
Yeah, and it just kind of turned into bouncing back and forth between my advisor and the placement tester, and neither of them knew the answer. So I just kind of gave up on it and figured I'd finish out this class because why not?
Okay. Yeah, I might be able to. I don't know. So, get answer from Athens or something. Okay. All right.
Alrighty, well, thank you.